Okay. So what I was saying that this one you can go through all of these and you can do all of these examples here. There is this is a tent function. These tent functions, you guys, you did them in the dynamical systems. I remember you did those who did the dynamical systems with Dr. Juliet Nakakawa. You talked of tent functions, and these tent functions, you discussed them under what we call discrete dynamical systems. You discussed this under discrete dynamical systems. And for those of you who never crammed, remember when you talked of the tent functions under discrete dynamical systems, and you went ahead and discussed those, you could even have established them using the cobweb theory. Okay, so I'm sure the terminologies here are not new to you, especially if you are not. These people who are saying no, I suspect you are the crammers. You know, your crammer forgets very fast. I am saying in the dynamical systems, you looked at tent functions and discrete dynamical systems. This which was done by Dr. Juliet Nakakawa. But as always, crammers forget very fast. Those who have forgotten, ask the friends in the neighborhood to remind you that you did that. These are all yours, guys. You are now the stars. These ones are all. When you talk of redefining a function, this is not new. You can even in the calculus 1, you did the redefinitions or what we used to call removing discontinuities. So there is an example here which is given on a half range, given the function, that one. You are told to redefine it so that it is having a period 4 extension. And all of these periods, you discussed them, by the way, in discrete dynamical systems. Those with the notes, you can go and you check, but I am certain you did this under discrete dynamical systems, and you also did these periodic functions in the dynamical systems. Remember, I told you this course, the courses that are prerequisites is the easy one and the dynamical systems, and of course the calculus 1 and the calculus 2. Okay, so this is just an illustration of how you could extend this to a 4 period, and by 4 period, the extension, remember this is simply 2 once you include the OR range for this one, that is from -2 to 0. You realize you have that, because if you sketch this from 0 to 2, you can throw in values of t, and you look at the sketch of this graph between -2 and 0. Okay, and that's why we are saying, what if our ft takes on a negative? That is this step here. Then you will end up with -2t minus t squared. Okay, you go and do all of these ones. These are yours. Okay, we can talk about convergence and the divergence of a Fourier series, and this one takes us back again to calculus 1. We bring in concepts of 1, limit theory, and of course there is some small component of reanalysis because of the language that is used, the convergence. Those who have done, I think you've all probably done reanalysis, but this doesn't dig deep. It is just a basic mention of a few of a few concepts in reanalysis. So let's just look at the theorem. There is nothing really big here. It's just the notation, and I am saying from your calculus, one of the notation should be very okay. So we are going to blend the concepts or some background of calculus 1 into this, and then the notation I'm sure you are already comfortable with, because this notation you have already used in limit theory. Okay, so point-wise convergence of a Fourier series, we have here some theorem. If you have f and then its derivative, if they are piecewise continuous on this interval here, then f has a Fourier expansion of the form, that one. This is an approximation. You have to be a little bit mindful. So because of the convergence, because you know sometimes when you want to establish convergence, you may use convergence may be implied given the approach one takes to ascertain it. So here we are saying fx, the function, the Fourier series function will follow this kind of expression, which is a naught over that. This one you already know. And if that is true, because it is convergence, then we are saying for this we will have then you look at x, of course here x, you are looking at x being approached from the left and the right. But what does this imply? Remember here when we talk of this being 2L periodic or L periodic, if it is a half range, this would imply that in that interval from minus L to L, because you have L, you have 0, then the question is which domain or which kind of range are you exactly working with respect to? That is what we are trying to refer to here. That's why we say for f of x, and then here it depends on where you are lying within that interval. That's why we bring in the plus and the minus. And if you do a direct substitution, this will be the minus L, but approaching from the right, and this is L, but approaching from the left. And that is picked from here. X is simply plus minus L, which is directly picked from the interval. Okay. What we are recalling here is also directly associated with the calculus 1. Remember, in the calculus 1, we talked of discontinuities. And those discontinuities, that's why we are talking of a jump discontinuity. Guys, give me a second, please. A second.